Hello everyone! You are back with us at the office in Ludinio, in Limassol, Cyprus. It's already September, and it's not as hot, which is very nice. In this episode, we decided to tell it like it is, how we spent the summer, how we spent a long time searching for an interesting approach to automation in the game that would perform well in playtests, how nothing was working out for us, how we were close to starting to implement Plan B, which was scheduled for the 1st of September. But like in a good movie, a few weeks before we completely lost hope, a miracle happened and somehow everything started working. In general, classic game development. I hope you really enjoy it, and be sure to write in the comments if you also have something like this, where you try to implement an interesting idea, improve it, but when faced with players or users, nothing happens, no chemistry. We hope it will be fun, interesting and useful, and please do not hesitate to write to us on Discord or here on the YouTube channel, in the comments or wherever you are watching this video. We are always happy to chat, and very soon Steam playtests will begin. On Steam you will be able to play a cooperative version with friends on Mac, Linux and Windows. In general, it will also be available in the browser. Come join us, we will be very glad.
Before actually starting the project, we had some projects behind us as a studio about automation, system design, things like that. These include games that I didn't make, like Learning Factory, a bit of While True Learn. We made Craftomation 101 with the guys. These are games directly about system design, about automation at their core. So the next logical step was to combine this into a cooperative experience. Because, well, co-op makes everything better. And in general, for example, in Craftomation, there were often moments when, well, I'm making a system, but I wish I were making the system with a friend. That's how we came to this idea. But we also wanted to break free from the eternal curse that, oh, well, these are programming games, so they're for those few strange geeks, not for me. We wanted to make programming and automation more accessible, closer, more understandable, and cooperative. Based on this, we started making SuperWEIRD. Where did we initially go? At its core, Craftomation was a game about automating individual robots through complex blueprints. Initially, the idea was to take some kind of programming system, individual per robot, and fit it into a system that would be understandable to people, a wider audience, with a more understandable interface, simpler primitives of what can be done, but with a lower entry threshold. We tried to introduce some automation. At that moment, we went to our programmer at the time, Andrei, and said, Andrei, we need some compatible interface so that it can be played with other gamepad and we can program robots through it. Andrei went off to think for a while. We drew a diagram with squares where we combined tracks with each other. And then there was a cool idea, like a command Tetris. In general, we wrote it all down and sketched it. And Andrei said, wow, great, cool idea. He left and came back to us with a programming ring. Well, this ring looked like, and still looks like actually, a good solution to the programming interface problem. It is well suited for gamepads. It looks quite user-friendly. More or less, it's clear what's happening here, right out of the box. The theory turned out beautifully, but our automation lived in playtests with real people. That's a separate story. Initially, we brought automation there with a programming ring per robot, so to speak. People on Poki apparently were not ready for the greatness of our system because, well, the metrics were so-so. Judging by the playtests I observed, people didn't really understand what was happening. They looked at this programming interface and then ran off to chop trees. We scratched our heads and decided that we probably need to create predefined code so that when you buy a robot, it immediately runs and shows its usefulness. With this, things went a bit better in terms of metrics slightly improving, but overall playtests showed us that then the person simply doesn't play with the robots because they complete their task, carry logs, and the player wasn't really playing automation. The player was playing the shop around this automation and didn't particularly interact with the robot. We thought that maybe the metrics are disappointing because we're missing something in the environment. The store isn't very fun. We actually conducted quite a lot of iterations to improve the entire flow around the automation of the store itself. And again, it somehow didn't work out very well, so to speak. In general, we concluded that maybe we need to try a different approach. Oleg and I were sitting, drinking coffee, thinking about what we could come up with for the design, tossing around ideas. And I had this thought for a long time that it would be cool to turn craftomation towards programming all the robots with external effectors, like programming them all at once. And in my mind, it always seemed like a reference to computer networks. Here you have packets flying along branched route with a router, a switch, a balancer at each node, distributing everything wisely. And so I had the thought that it would be cool to make a game about flags so that robots, like in a computer network, only walked by road signs. We laughed a bit, finished our coffee and went back to work. Well, we discussed this idea, but it just came and went. Then sometime later, when we had another creative block, we were throwing around ideas again, one after another. I tried to organize them in my head to write a design document. The design document was falling apart. At some point, while having coffee again, Oleg said, remember those flags? That was a cool idea. I said, well, yeah, it was. And we started to elaborate on it, and somehow it seemed to fit, and its reference was clear. So, router in networks is, well, for those who have seen how it works on diagrams, it's quite a fascinating thing. A significant challenge was to make tangible objects on the map work like network packets. That is, a network packet has a time to live, and then it kind of gets annihilated in the network, and that's it. And this makes network architecture cool because you have an infinite stream from point A to point B. And at point B, they either continue or disperse. And you always know that the stream will be roughly equally loaded. In the case of, say, robots, it's not as obvious how to solve this. Therefore, we concluded that our robots are low quality, falling apart, precisely to create that sense of flow, that they move, fall apart, but keep going. And out of 100 robots, you lost 20, but overall it doesn't matter because 80 keep going. Actually, it looks pretty cool that you're conducting streams on the map. And it seems to give depth too, because you can have a lot written on the flag. Robot tags, the sorting task immediately appears, priority distribution tasks immediately appear, load balancing immediately appears. And it looked like a cool solution because now we are not programming each individual unit, but programming the map and everything happening on the map, allowing the player to think less about the details of control, so to speak. It seems to work better in co-op because you have many points of interaction on the map with which each player can independently do something and adjust, and the overall scheme will change. That's why we decided to try these flags and make several iterations with them. In the basic version, it naturally didn't perform particularly well either, but unlike previous versions, iterations here showed some progress. That is, we did something, improved something, and it grew little by little. That's why we decided to iterate in this direction, and there were quite a lot of iterations. There were tens of thousands of playtests on Poki. Obviously not all of them, to put it mildly, were watched by us, but we collected metrics. And in general, as a result, iteratively, iteration by iteration, hundreds of playtests after hundreds of playtests, we somehow pushed these flags to the point where they performed quite well and were one of the few concepts that did not break against the Poki audience. I am still surprised that flags work in some form on Poki and show some metrics because, well, if you browse the Poki portal, you can see that the games there are not very deep, and flags are quite a deep mechanic. I like it, it's cool, it gives you a sense of a system, but the fact that it performs on Poki is quite surprising to me. And, well, probably this is some kind of our victory, quite significant, which I cannot be dissatisfied with. What does the flag system currently look like? It now has 2 implementations. Let's start with that. In one version of the game, these are direct streams from robots distributed with arrows. Each has a slider indicating what percentage goes where, and that's how you balance production. This leads, on one hand, to everything being very tactile and understandable, and on the other hand, this leads to very long chains of this sequential splitters, which had to be constantly adjusted and fine-tuned for perfect proportions. We even had people in playtesting who drew the scheme on paper, calculated and multiplied the percentages. Of course, we had the task of creating an educational game, but not in this sense, I think. This is how the first version looks like. The second version of the flags it's a version where, similar to RimWorld, you have task flags, and each task flag has its own priority. By adjusting priorities, you manage the distribution of robots according to these priorities. There are no splitters. Essentially, you are playing assign robots to tasks. In fact, knowing how it's done, it was fun to play. And even by the metrics, surprisingly, it showed results almost the same as the build with splitters. But this system has a major problem. People started coming to us at FES, and we handed them the game directly. None of the people who came in for playtests really understood what was going on. Both of these systems work well at the beginning, but increasingly descend into chaos in the late game. Well, even by the 20th minute, not necessarily in the deep late game. And actually that's why we tried to merge them and came up with a load balancer at their junction, which combines direction selection and load distribution across these directions. A particular joy is that within the concept of flags, the programming ring is still with us. It hasn't gone anywhere. Now we just program flags with the ring. It's joyful, it's cool, and it feels quite organic. It seems like at this point our design has come together, and it seems to have turned out pretty well and understandable. Sometimes when you're doing something, you realize that some feature is off to the side. You have to play a game in your head. If you play the game in your head well enough, you notice in time that some feature is falling off. Do not be afraid to discard features, because during development, something will definitely fall off. It never happens that you come up with a game with 230 features, and all 230 features stay with you from start to finish. Some part will always end up dropping off along the way.
And be sure to subscribe to this channel, because there will be a lot about how we do things. And if you write to us, for example, that you want to know how exactly we make animations, how exactly we do some part of the code, how exactly we draw, we will film all of this without any problem. We want people to better understand how games are made, both the pros and cons, all sides as they are, and we will gladly film it and post it for you, and maybe together we'll make a really great game someday, or maybe you'll make a great game and we'll enjoy playing it. Good luck!